Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I do data science and data engineering at Databricks. And I'm joined by my co-host,
Ben Wilson. I review PRs at Databricks.
Today we are going to be talking about how to design a product. And this is something that Ben thinks about many times a day, and sometimes even at night. And I have also been thinking about it recently because for a lot of customer implementations, they say, here's a problem, fix it with a solution. And sometimes that's sort of challenging. You don't want to just start typing without thinking about how things should be designed. So, Ben, you said before we started recording what separates a billion-dollar company from something else. Do you mind restating that?
Not in the same words, I don't think. You know the acronyms that everybody uses, right? FANG company, which isn't even technically applicable anymore, but those type of high-tech companies that they dominate in their space, they hire the best engineers, they have the best product teams, they have this amazing vision and, arguably a monopoly in their space that the SEC hasn't investigated yet. But they're so successful and capable of producing things that it seems like nobody else can do, which isn't true. But the thing that sets those companies apart from people that are, hiring software engineers and hiring data scientists and ML people that are putting stuff into production, in my opinion, and this is just my opinion, but I think the fundamental thing that sets those groups of people apart from one another is process. And I'm pausing there for a moment just to let that sink in.
Wait, so hold on. So you're telling
skill.
me that it's not the person, it's not the intelligence, it's not their fancy Harvard degree, it's just the culture and the process and the organization?
Yeah. So from my experience and talking to a number of different people who have worked at those companies, those big high-tech FANG companies, like most of our engineering department comes from that background, or they come from, a very fancy Ivy League background. They're very smart people. They're very capable, but everybody, regardless of which of those big tech companies they come from, they all fit in seamlessly into how we do business because we behave in the same way of there's a process and there's a set of things that are done that has been learned over many decades throughout the industry of effective and efficient ways of building things in complex systems. And then I also come from a background before where I worked at companies that didn't have that. We still had brilliant people working there. A lot of them I noticed were really frustrated with how things happened or how things were done at a small startup or in an industry that is not software first, right? So their business is about something else, but they just happen to have, you need a software team. And really good people were just like, man, why do we keep on shipping broken stuff? Or why did we build this thing that nobody uses? Or why was this allowed to actually merge to production? It's garbage and it's broken and I'm getting paged all hours of the night because of this garbage code. Or this doesn't scale. Or, there's all these issues that come up. And even at the big tech companies, you have that, right? We're human. We're infallible. Like nobody's infallible. We create broken stuff all the time. The difference is it doesn't happen as frequently and as insidiously at the big tech companies because you can't have that. And it's not because you hire, savants and fill all of your teams with, the most brilliant geniuses on planet Earth, software gods and goddesses. It's not how it works. It's about process. You get smart people, and there's smart people everywhere. They're working at those tiny startups. They're working at companies that are not software first, and they're also working at the tech giants. But if you were to take a room full of geniuses and give them carte blanche to do whatever they thought was right individually and provided no guardrails whatsoever, see what that team produces in a year versus a team of smart but not genius level people, and give them process of, this is how we think through design, this is how we build software, this is how we build product. See which one is going to produce more successful outcomes for their user base. It's going to be the second team, hands down. Promise you.
Got it. So that's a pretty freaking bold statement that process is the key, and the intellectual property of these organizations arguably should be the process. Yes, the code that was generated from the process is valuable and actually is what makes the money, but the process is the leg up or the advantage that these companies have over other companies. Is that
Yeah,
about
because
right?
you're not going to have that IP if you don't have some sort of rule set about how you build that, or
Got
it's
it.
going to fall apart and you're going to have a broken product or a broken platform. You know, what would it be like if Netflix, created a streaming backend service that went down every 2 hours? Like, just completely, you know, zero response, paginating buffering video for an hour because the thing just went down in the back end. Everybody would cancel their subscription. Everybody would bail. They'd be like, this sucks. This thing doesn't even work. What am I paying for? You can't have that. So it's not that Netflix has, the world's smartest human beings all working and everybody building whatever they think is right. It's not how that works. You have a bunch of super smart people working together around a process of how to build and how to introduce features. And not just the engineers, you have the product team that's working with those engineers. You have the entire support staff that's making sure that there's this vision of how things are built and how things are tested and how they're deployed.
So, okay, I'm sort of on board. And before we get into the actual product design piece and then some tips and tricks, why then are all of these FANG companies paying so much money for software engineers, ML engineers, that type of thing, if it's not about the people?
I mean, it is about the people. So if you were to take a mediocre, person, uh, somebody who, if given a new feature to develop, might take them 3 weeks to build, versus somebody that you give the same guidelines and same process and they get that code shipped in 2 days. Who are you going to hire? Right? That that capability that some people have where they can do things really well, efficiently, work with other people. They're nice, they're kind, they're empathetic. You pay money for that. You pay money for, top talent, people that can work with others and get stuff done. So they pay more because they want to keep those good people. And those people who are receiving those paychecks, they're not idiots. They're not going to be like, "Oh, it's fine. I'll I'll take half that pay. No big deal." You know?
But the basis of that question was you said that it's about the process and not the people. And that might be oversimplifying, but can you
Sure.
clarify why you should be paying so much if you can just train someone up in 2 years to have the exact same skill set?
You can train anybody up to, at regardless of time. If you take time to market out of the equation, anybody who is sufficiently skilled enough to be able to produce that final result, right? They know the fundamentals of computer science, they know how to solve a problem with code. If you can train anybody up with guardrails and a process on how to actually get that built in a sustainable way. The reason that some people get paid way more than other people is really that time factor. How long is it going to take for that person to get through the process of figuring out how to get this done in an efficient way and solve all of those problems and have context and have the ability to do independent research to learn as they're going to get better as they're going. So yeah, people are different, of course, and have different capacities for performance. And that's really what the big tech companies are looking for is people that are they stand out from the crowd. Hey, they're an exceptional person at what they do.
Got it. So it sounds like you're saying that you can train up someone to be sort of in the 90th percentile just by correct process, but that top 10% of people, there is some natural talent, and there's just time factors of having done the right process for a long period of time that makes them more valuable than a recently trained person. Is that correct?
If we're talking happy path, yeah. Uh, however, these aren't mutually exclusive. It's not like, oh, all geniuses are going to figure out the best way to produce software. So you can take not just saying like, hey, we'll take that mediocre person and compare them against a genius. And the genius without any guidance is going to be able to, do this amazing thing in a fraction of the time of the mediocre person. It's not how it works. That genius without that process is going to make garbage. I promise you. They might get lucky, a couple of times and make something that's super awesome. And then you merge it into production, you deploy it, and then you find out that they made decisions that are incompatible with the rest of the software suite or services that you have because they didn't have context. They didn't know that, hey, I needed to get approval from these other 10 teams that have to interface with this thing. I just broke the ability for us to release this product because I put in all this effort and work to build this new feature that can't talk to anything else. So the like geniuses can actually cause more harm if you don't have process because they build stuff faster and get stuff out there quicker. And
Right.
yeah, you can create even more havoc with
Got it.
those people.
Okay, cool. I think I understand. So now let's get into some tips and tricks, and I'll start off the tips and tricks with a real world use case. Prior to the new year, I was working with a large retail organization, and they have been using Databricks for a couple years. And they said, "Hey, Michael, do you mind designing a data ingestion framework for us?" It's like, "Sure, that is squarely my job, so I will do that." And I built some prototypes and said, "Hey, what do you guys think?" I didn't even go through the process of building a design doc. I just built prototypes and was like, "Hey, do you think you could maintain this? Would this meet your needs? Give me feedback." And they said, "Yeah, looks good to me." And 3 weeks later, they started onboarding a bunch of teams to use this in a production setting. I hadn't written tests. I frankly put that together in like a week max. There was no design doc, and so I immediately said, "Let's pump the brakes a bit and let's figure out if this is actually meeting your use cases, and let's do sort of a beta test." And so that's where we're at now, and it's at a good place. But this process seemed a little bit rushed, and it was not what I intended to have happen. So, Ben, if you were put in this position and you were the customer that I was working with, how would you go about approaching this ingestion framework that is theoretically going to handle thousands of data pipelines with terabytes of data being ingested over, let's say, a week period? How would you go about ensuring this would meet the quality and standards of your organization for the next 5 to 10 years?
Interesting question. So you use the word framework, which is interesting to me. So in the realm of software engineering, a framework would be something like Apache Spark. That's a framework for doing ETL. So you're able to deserialize data, put it into in memory. You have data transformation tools. You can, you know, run libraries on top of this system, and it gives you a mechanism for, in the sense of ETL, you load the data, extract it, do your transformations on it, and then you put it somewhere. So if I'm a customer, asking for a framework, I would expect that the consultant that I'm talking to explain to me that we're not looking for a framework. We're looking for an abstraction over an existing framework that is customized to how the business does what it does. That being said, um, if I wanted a unified framework that is customized to how, we have all of our data in this one storage format, and I just need it to be transformable into this particular architecture of fanning out, you know, medallion data. So I need to put my raw data in bronze, and then I have this augmented data in silver. It's cleaned. And then I have gold tables that are used for analytics, like pre-computed aggregations and stuff. That's just like an ETL pipeline. And if that's what I wanted a consultant to do, I would say, like, I would list out, here's all the jobs that we need done, and all of the data sets at the end. Here's their actual, entity diagrams. Here's the data model of what I want you to create. Go build that. So at that point, I would be the one designing it and then getting approval internally at my company saying, is this what we want? Is this what we want this consultant to help us with? And the design would be provided for the consultant to just go and, hey, just go build, like, write the code for this and make sure it works, and prove to me at the end of your contract that you built what I asked you to build. Else you're going to go fix it.
Yeah, let me clarify what the use case was. They did not know what a single pipeline should look like. They wanted internal processes so that they can scalably build and deploy data pipelines. So,
Scalably build and deploy. I mean, that's Spark. Like that, like Spark is the framework that enables that.
all right,
What
so
they want to
let's say
apply
that the
pipelines.
data engineers that are actually building the pipeline are not super technical, and they want to be able to ensure, ideally have some templates that the data engineers could use, ensure there's data quality. So make sure that there's data validation both in flight and post table creation. And yeah, they just basically want internal processes. I think that's a better way to put it. And ideally, there's like a utils package that you can just import and say, all right, I changed these 6 parameters. It will do this task and it will work every single time.
Okay, so they want a custom DML on top of a framework. They
Sure.
want config based pipeline orchestration. Like, you can get that in like pure open source by using something like Airflow. It's just like a config based, like, here's my YAML config, or here's my JSON that defines what the input and output is, and here's some transformation logic that I can write in SQL or something. And Spark supports that. Like, Databricks supports that. It's one of the benefits of the platform. And I'm all for doing stuff like that. My question to that customer would be, okay, your data engineers, by virtue of that job title, they should be able to write these. Like, that's a core requirement in industry for a data engineer. Like, you should be able to write Python or Java or whatever, SQL code, whatever it is. If it's manipulating data, you should be able to write that and write a pipeline. Um, and so if somebody comes back and says, like, well, my people don't really want to do that. They just want to write JSON or YAML configs. It's like, okay, we'll build, something where you can specify a configuration, which will then use some sort of builder pattern to construct a pipeline that does these actions. I would, at that point, if that's what somebody told me, I would say, now we really need to design this. And we need to know what this thing can and can't do, what it should and should not do, and what it will not do, so that all of that is documented very well for the people who are going to be using this, and also for the people who are going to be maintaining this and building additional features in the future.
Right.
And something like that would scare me if I was assigned a task like that. 'Cause I would it wouldn't scare me if the person I'm talking to was like, "Hey, I know exactly what we need to do. Here's our product requirements for this. Let's, work on a design together that we can, meet these needs." And then clearly articulate to the end users and management like, "Hey, this is not gonna solve these problems, but it'll solve this big list that we want."
Got it. So you were alluding to something that I think is a valuable technique of defining what it must have, what it should, could, and won't have. Can you clarify sort of the history of this and the value of defining these in a simple bullet list?
So the simple bullet list is the TLDR of your work that you did while doing your research. So if you have engineer in your job title somewhere, uh, whether it's software or traditional dealing with mechanical or electrical or nuclear or whatever, uh, you should be thinking about this thing, like these topics while you're determining whether something is feasible or not. And that prototype research phase is you figuring out what is actually possible. And it's not a let's boil the ocean and figure out all the things that this thing could do. That's a massive waste of time and completely irrelevant. You should always have that product requirement of here's the one or two sentences explaining what this project is supposed to do. I need a simple interface for non-developers, like DBAs, basically, who can move data from one place to another and apply simple transformations. So if that's our mission statement, that gives me guardrails immediately of like, okay, what manipulations could we do to the data within the confines of how this business deals with data? What source systems do you have? Like, where is this data? Are we pulling data in raw JSON format from web traffic, or is this, you know, tabular data that's stored in some data lake somewhere? Like, I would need to know all that stuff to know like what do we have to think about in the grand design of what we were potentially could be building.
Right. Yeah, that's an interesting point. So starting off with a clear and concise problem statement, and then following that up with research, and also I like that you mentioned that you just immediately jump in and try things. And I've been doing that more and more recently, and I've found that really valuable. Switching to another thing that we can actually discuss fully openly, we just finished converting a lot of the doc strings in MLflow to Google format. And I was working on that using OpenAI and just using an LLM to convert. And we were looking to see if we can enforce Google style. So instead of having the colon param, you have args and the Google style docstring. And the first thing that I did was I cloned the repo and just started trying shit. I Googled around, I asked ChatGPT to do it for me. I looked at Stack Overflow and just tried to figure out what could happen. And I ended up changing a bunch of rules in our linter, which is a Rust-based tool called Rough, and basically added a few rules, removed a few rules, ended up changing something like 30,000 lines of the MLflow repository, and then PR'd it just to see how that would look in the CI build. And of course, it exploded. But just within that hour, I got so much amazing information just by playing and just by trying things. And if
Mhm.
there was an error, I stopped and tried something else. I had no goal, I was just looking around. From that, I'm going to take a step back and say, all right, these are the six things I tried. This is the pros and cons of each, and this is what I think we should do. And then I'll PR that and then look for feedback. And so this process is super, super valuable where you can just go and try things and break stuff. Breaking things is incredibly valuable. And you don't always have to have sort of a methodical approach in this prototyping phase. So after that research and building, um, now we sort of get into the design decisions. What does that look like? Is it this Moscow list, or are there additional components of the design doc that should be built out?
So your design decisions are meant to there's a couple of purposes. Uh, one is there's Like during your research, you found a fork in the road. You're like, hey, I tried 10 things in the hour that I gave myself to decide how we might want to solve this big problem associated with the design. And out of those 10 things, three of them, they all kind of worked. And I really like the first two. I hate the third one, but I don't have enough context to make a decision here on what is the right way to do this. So I need to dig in a little bit deeper and start thinking about what are the potential pros and cons of these three options. And then you write those down. And writing them down isn't for you. I mean, it does help you. It helps you kind of think through the problem and look at it and be like, am I capturing the pros and cons here? Like, what did I not think of? What could potentially go wrong? Maybe this decision and its three options that I'm going with has impacts on another decision that I need to make. So let me go down that, one layer deep into the rabbit hole and figure out, is this compatible with this other part that's tightly coupled here? And you might be able to cull out the like one of those. You might be like, hey, option three just doesn't work. It worked for like while I was doing the first part of this, but then the second part it's totally broken. So I can delete that. But between the option one and two, if you look at interrelated things or things that you might want to, you know, integrate with later on, or you never know. Like we're speaking in very abstract terms, so each each case is going to be different, but you definitely want to think about how is this going to burn me in the future or burn my team or burn my company. And that's really what putting that stuff down is for. Help you think through those things, help you see it in front of you in text or in diagrams, whatever it needs to be. And then the follow on benefit of this is you get that peer reviewed. So these design docs, they're peer reviewed. They have to be. It's super dangerous if you're like the one person doing all this stuff and we like nobody is capable of thinking of all of the possible things that could go wrong or go right, or alternatives that you could have. Everybody's got history of experiences of things that they've built or things that they've broken. And that's why a big diverse team of people from different backgrounds always builds better stuff than one person working on their own. And that's why the peer review process is so important. It's not just, hey, my boss, who's like way more senior than me, they signed off on this. They said it's good. They're not going to have all the context. Maybe somebody who's more junior than you in years, who's also on your team, has a point of view that's actually valid. It says, hey, I think this might actually blow up because I did this thing like 3 years ago and I broke something like this. And then you go and explore that and you're like, yeah, they're right. Cool. Well, let's not do that.
Right. Yeah. So I have a bunch of questions on this phase. The first one I'll set up with a learning that I had a while ago. So you probably 6 or 8 months ago first defined the term implementation detail to me, and it really stuck. It's basically the concept of something that you can figure out later. It's as simple as that. And when you're working through a very complex design or just a complex system in general, it's hard to differentiate design decisions from implementation details. And it's even harder if you're not super well versed in the stack or if you haven't built things like this before. So, question number one: what is your rule of thumb for differentiating a design decision versus an implementation detail?
Uh, so what you just described doesn't come up that often in our teams. It did come up for me at companies I've worked at before, and certainly companies I've helped out when I was working in the field. Uh, you would see like implementation details bleed over into design docs in teams that don't have technical competency. And it's natural. It's not like, oh, this is terrible if you do this. You're an idiot if you do that. It's it's irrelevant to a team that has high technical competency, because everybody on the team and everybody who's reviewing the design decision knows whether something's possible or not. So if you know enough about computer software when you're doing one of these things, you know what you can and can't do with a linked list. You know what in Python what a dictionary can and can't do. You know when to use a dictionary versus when to use a set, when to use, list comprehension versus for loops. Those are all nuances that are like core CS, like fundamentals. And you ensure that everybody working on software at your company has those competencies when they get interviewed for a job at the company. So you don't need to put all that stuff in there. It's irrelevant. Everybody knows that you'll figure it out, right? That's the technical aspect of building something. What you don't want to do is make a decision on something that has to do with architecture and just assume that everybody like groks what's going to go on. So an example would be an implementation detail would be like, hey, are we going to store metadata about this object that we're recording information on? And the design decision in that situation would be Boolean. We're either, yes, we're going to store metadata, or no, we're not going to store metadata. An implementation detail would be, are we going to store this temporarily in a data class in Python, or are we going to use a named tuple? Nobody cares, dude. Like, we'll figure that out when it comes to it. And that's an implementation detail that is so irrelevant to the point of whether we're going to save metadata, yes or no. So the design decision is at the heart of what are we going to build, not how are we going to build it.
Yeah. So let me be really annoying here, and I have some solutions, but I'll still be annoying. So I think you hit the nail on the head with the comment about when you're hired, you should have some sort of technical baseline. But my question to you is, how do you handle this if you're working out of your technical capacity or working with people who, when reviewing this, it will be out of their technical capacity? And taking an extreme example, oftentimes I'm designing things for customers that have they're not very advanced, but they have Databricks features that are not generally known to most data engineers, let's say, or they're small components that they just haven't seen before. And so, should I go and spell it out for them, or should I just have enough confidence to trust myself? Or is there some sort of middle ground? And conversely, on their side, if they don't know about the Databricks features, for instance, how do they go about defining what is feasible and thereby what is a decision versus an implementation detail?
So that's what you figure out in a prototype. So your prototype code doesn't necessarily need to be in your design, but it's super helpful if it is. You've seen tons of my designs that I've done. They're filled with code.
Yeah.
That's just how I do them. I'm a nerd that way. I've seen other people's designs where there's not a single line of code because they don't need to do that. It's not a requirement, or what they're designing doesn't really need to be explained. Like the concept can be communicated with just English. And then there's other things where you see somebody's design doc and you're like, hey, this is like 95% code samples. Uh, that's cool. Maybe a bit much, but hey, it works. Just make sure that that complexity fits what you're working on and what you're designing. But before you go through and figure out what design decisions there are, you should do a really quick, nasty prototype. And by nasty, I mean it really doesn't have to look good. Write a function that serves a purpose of doing just the bare minimum of what you're trying to prove out. For the example of metadata, right? That's trivial, but if we wanted to show how we're going to like one potential avenue of how are we going to get information out of this object. Write a function that takes in that object and then strips out the information from it, puts it in, a dictionary and returns that. Is that what the final code is going to be? Probably not. Doesn't matter. But I wouldn't put that code in the design doc because I know that everybody who would see that would be like, "Yeah, dude, like we get what you're saying here. Take the metadata. We got it. Know your audience, basically." But if it's something like, "Hey, I'm interfacing with this library that nobody here has any experience with because we've never had to import it ever in anything that we do, and it's 3 months old and it's super popular and everybody's using it, but we don't know it yet." I'll go out of my way to do a ton of prototyping on this thing to show myself and my audience, and to show my audience who's going to be reading this document that I did my homework to validate that these things are actually either possible or not possible. And that's that hidden purpose. One of the hidden purposes of a design doc is to communicate that you looked at all this stuff so that people are like, yeah, this person, they were thorough. They went through and validated all this stuff. So we're okay with signing off on this.
Yeah. Yeah, it actually hits home when you mentioned logging metadata. This was actually something that I've struggled with some of the designs in the past. And it's because I am not super comfortable with all of the different ways you can log metadata and uh, basically how to handle it asynchronously, how to ensure that reads are super fast and writes are super fast. How do you condense the table after logging the metadata? There's all these components that if you don't go and build a bunch of prototypes, it can be challenging. But my
Mm.
question to you is, all right, if I'm prototyping, there's theoretically an entire world of software that I would have to learn, and that could take at least a couple days, upwards of a few years. How do you define the cutoff between I should figure it out myself versus I should ask someone?
It depends. So if you're presented with a fairly straightforward problem and you don't know where to even start, phone a friend. Like, ask a more senior person. You should have a mentor that is assigned to you, or some tech lead who can kind of point you in the direction. Be like, I don't know the exact answer here, but here's what I would do. And usually those people have enough experience that they can give you the correct vector in which to start your journey. But if you're experienced and you've been around for a long time doing this stuff, and this is your 800th design that you've done, and you're presented with a problem that there is no clear answer on how you would even begin to start solving this problem, then designs are even more important, because now you have to start thinking of, is there something that exists even within this language that we all are writing in that supports this mechanism that we're trying to do? Is there some package that somebody wrote that solves this problem that we can use? What is there that we can leverage to solve this? And if you exhaustively go through all of your resources of knowing where to go, who to ask, getting other opinions, sitting down in a roundtable discussion with a bunch of other senior people, like, do we have to like build this from scratch ourselves? Like, create a new library that does this functionality? And if that's the case, you write that down and you get a peer group of very senior people that all agree, like, hey, this is not possible unless we do this. We need to write a new C++ library that does this thing, and then put a Python wrapper around it, and then we'll interface with that. That now becomes a requirement to meet the need of whatever you're trying to do. And then you weigh whether it's worth it to do that or not. In the case of everything that I've worked on at Databricks, uh, usually 99% of the time, when we see something like that, and we have seen, you know, requests that are like that. We're like, well, in order to do this, we would need to build this entire library to do this. We'll go through the motions of listing that out and saying, okay, this is going to take us 6 months to build. Is this worth it? And then, you know, product and engineering management will look at that and be like, yeah, let's not do that. Let's go do this other thing that's kind of similar to that that we can get done in 2 weeks, and it's going to meet 90% of the use cases. And those edge cases that are not supportable, they're not supportable.
Right. Okay, I think I understand. And just sort of reflecting a little bit, it seems like this is one of the core values of having a wide knowledge base is the speed at which you can design things. If you've built 7 different versions of logging metadata, well, you can pretty quickly say this is the best one we should use, this is why, and build out that pros and cons list with minimal prototyping. But if you haven't done that type of thing in the past, sometimes it's a bit more challenging because you actually have to go in and test things out, and it just takes a longer time. So, Ben, opening the floor a little bit, do you have any general tips that you on the ML Flow team use to make your team more effective that other people can employ?
I mean, the big thing to remember is we're not going through and doing designs for every feature that we build. There are probably like 90, high 90s percentage of feature PRs that are filed and merged from our team have no design associated with them. We don't need it. The team is freaking incredible and they know how to build stuff. So if it's something that is very clear in one or two sentences of like, hey, we need to build this thing, and you're on our stand-ups, you see like what we work on and how we talk with one another and where we get stuck on certain things, what needs discussion. And sometimes you'll see, oh, filed this PR. We open it, look at it for a couple of seconds and be like, yep, cool. We'll take a look and see if we see any typos or anything. But usually it's like, yeah, it's pretty good. It's knowing when you have to do that 4 to 5% of, hey, this is big. This entire feature is going to be maybe 20 or 30 PRs to build this. And the reason that you go through that whole design process is not just to make sure you're building perfection. That's illusory and not real, by the way. You're always going to there's always going to be a better way to build something. There's always going to be like a more efficient way of writing your code, or are we building for performance, or are we building for readability, or are we building for testability? There's so many questions, so many different interpretations. That's why software development is an art as well as a science. And because of all of those, like that limitation on perfection, you're never going to hit anybody's subjective or objective version of perfection with an implementation. What you're trying to do is minimize the loss of time. That's the end goal. It's all about velocity, man. Like, how many people do you have? How many hours in a work week can people productively work on new things or work on fixing broken things? And how can you minimize the amount of wasted time that those people have to go through? Because you get a bunch of brilliant people together, they really don't want to be just plugging the leaks in the boat all the time. They want to be working on cool stuff and building new things and building value that people actually use the cool stuff that they're building. That's the goal. That's why most people are in like open source development or working in software in general. Like, most of those people are nerdy people that want to build cool stuff that other people actually use. And that's what gives them joy. It's like, hey, I built this, or we built this together, and look how many people are using it and they love it. This is awesome. It's not, hey, look how smart I am. I'm the best. Nobody has that attitude. Everybody's like, man, I'm an idiot. I'm glad that this actually worked out. This is cool that people that are using it. And you do the design so that you have less stuff potentially to fix, or to prevent you from releasing something that people are excited about. Then they use it and they realize that it sucks or it's broken. You want to prevent that. Because if you use something that you think should work and then you use it, it's like, hey, hang on, this is totally broken, man. Are you going to try it again? Are you going to lose faith with the project or lose faith with the team that's working on it? Yeah, maybe. So it's all about making stuff that's not totally broken.
Yeah. So can you clarify things that are a loss of time? So I was thinking through a list. It seems like maintenance sort of required sometimes, but maintenance is a loss of time. Bug fixes, definitely a loss of time. Refactors, maybe a loss of time. Regressions, definitely a loss of time. And then things that aren't being used. So features that just don't add value. That's also a loss of time. Do you agree with all of those? And are there other things?
Kinda. So a regression is an incident. That's bad, like really bad. You broke something that used to work. Uh, I've done it. Everybody I know has done it who works in software engineering for more than 5 years. Uh, when you do that, it's an opportunity to learn, though. Like, hey, w- why did this happen? Not, hey, let's place blame on the person that broke it. It's how can we prevent this from happening again? Our process is broken in some way. How do we change our process in the execution of delivering code so that we don't have these sorts of failures happen again? So that's a serious incident, and it's usually like the fault of whoever was in charge of doing that. Right now, that's me. So the it's very much on like whoever the tech lead is to really take that to heart. Like, this is very bad that we did this, and I'm the reason that this broke, and I need to make sure that my team doesn't get exposed to this again. Yeah, it wastes a lot of time, but it also makes everything better. Uh, the waste of time, if it if you build something that every time you have to touch that code or interface with that code, it just feels painful. You're like, hey, we want to add this new feature to this, but every time we need to do that, we have to touch like 40 other places in the code in order to enable this new feature. That means your code architecture sucks, or you have a very complex product that could potentially benefit from refactoring. But usually when you're looking at tasks like that, it becomes a real problem when you can't refactor it because you don't have enough time. It's like, hey, in order to build this feature, we need to fix the code in such a way that it it's going to take 5 times longer to refactor the code than it is to build it, like the core feature. That's a problem, and design can help prevent that. But that's not. You don't really do that on product design. You do that on PR reviews. So when your peers are looking at the code, they're the ones who should be like, ah, let's change this to a different code architecture. Let's write this in a different way because you're putting 30 actions within this method. Let's break this method up into 10 different methods so that we can test them all and also decouple all of this logic because this is a highly or like something that's internal to this is something that's probably going to have to change a bit. And the more crap you pack into a single execution statement, the more dangerous it becomes when you have to modify that, which can cause a regression, which is bad. So that's technical competency. That's experience about knowing how to build stuff, separation of concerns, and focusing on code readability is big on that too. So if you can understand how something works just by glancing at it and be like, yeah, totally grok how that like what that's supposed to be doing. It's a minimal set of instructions that this function or this method is responsible for. Cool. But if you look at something and you're like, hang on a second, I'm going to need about an hour to go through this because there's so much going on here. this one function is 600 lines of code long. What the heck is happening here? You should be scared, and but you shouldn't be afraid to tell the person who wrote it, like, can you please write this so a human can read it? You know, the
Got
computer
it.
can read it just fine, but if other people don't understand what you wrote, how are they going to fix it when it breaks?
Yes, code is for humans. That's why we don't write in binary.
Exactly.
So all right, you touched on everything but one in that list, which is things that aren't being used. Does that
Dead
come
code?
in features, like a built feature that is not being used by the customer or whatever you're building, that the feature is not being used? Is that part of the design doc? Is that the responsibility of the TL to find product market fit? Like where whose responsibility is that? And would you count that as a loss of time if you build something and it doesn't get used?
No, engineering is not involved in that. Like that's product. um,
Got it.
but the tech lead works with product and should be communicating, and you should be analyzing if you have customers that are using something. Engineers don't. I mean, I haven't met any that, and I definitely include myself in this list, that are sort of emotionally attached to stuff like that. They're like, "Oh, I don't want to get rid of this feature. Like, I spent so much time on it." Every single one of us is like, "I want to kill that code. I want to delete it." How many can we pull the data on usage and see, is there less than 3 people that have used it this month? If so, can we delete that crap? Like, let them know, like, "Hey, we're getting rid of this." Slap deprecated on it and say, like, "We have you know, 850,000 users using these other APIs, and we have 3 people using these APIs. That's a waste of time, and when we have to do maintenance on this and update the code so that it works in a new environment or something, it's just a massive waste of time." So, being ruthless about deleting code that provides no benefit to anybody, you should be straight up, you should be ruthless about that. Like, the code doesn't care, it doesn't have feelings. And if the people on your team get upset at seeing their code disappear, I would question, like, who did I hire on this team? Like, why are they getting so emotionally attached to this? Because they should have enough experience to realize that anything you write is ephemeral. Somebody else is going to improve it or fix what you screwed up or make it better or add features to it or eventually delete the code. Once you get experienced enough, you start thinking back, you're like, I can't even remember what I wrote 6 months ago. Or you look through a commit history in a large repository. And that's the funniest thing that happens to me actually is I'm like, look at some function. I'm like, who the hell wrote this? Like, this is kind of crap. Like, who wrote this? And then I look and like, oh, Wilson. Yeah, that's me. Oh, let me fix that. I think that's funny when that happens. Uh, and it's also funny when the opposite happens, where you look at something, you're like, that's really clever. Huh. That's pretty cool that we have that in the code base. And you click on it and you're like, I wrote that? When did I'm not that smart. Like, when did I come up with this? So, but when you write enough code, stuff like that happens. And that means that you're no longer attached to that code. You don't even remember writing it. You don't care. You're focused on, am I building stuff that people want to use? Is it, is what I'm creating useful to people? That's really all that should matter. And if
Right.
it's not, delete it, get rid of it. It's a burden.
Yeah. But what if you used a list comprehension instead of a for loop and that's super fancy? Isn't that super painful for you to delete, Ben?
No, no. Um, a note on that. So, refactoring for efficiency is a massive pet peeve of mine and many of my peers. Uh, or people making comments in code about stuff like that where it's irrelevant. Um, so if you're going in and looking at how somebody built something and you're like, oh, I don't really like how they're doing this implementation, it's not very performant. And you look at it and you're like, this is called one time on a collection that never grows more than 10 elements deep. Like it can't grow further than that. Your efficiency improvement between a for loop and a list comprehension and a filter that's happening on that iterator, you're saving a tenth of a millisecond. The computer doesn't care. You're not saving anything here. So that comment should be focused on, we use list comprehensions because they're easier to read, because everywhere else that we're operating on collections uses list comprehensions. Let's do that because it's more readable, because for loops can get ugly when you look at them in Python. That's totally valid. Like, let's refactor for readability. But if somebody's going through and saying, I don't think we should use a dictionary comprehension, we should use set operations because that's more efficient for, the Python interpreter to, create the binary code in the just-in-time compiler. Nobody cares, because that'll make the code way more complex to start throwing a bunch of set operators in there, and you're having to cast things to different types and then recast it back to something else. So the code complexity increases for almost zero benefit. So that's where wisdom comes in. When you're doing PR reviews, to know what is important. And at the end of the day, the most important thing is, does the code work as intended? And then right behind that is, can we actually read it and understand it? And then below that is, if performance is not directly coupled to that first element, like does it work or not? Which that's a huge different, that's a very different concept when we're talking about collection operations. If we're iterating over 10 million elements in a collection, then those little things matter. Are we doing like some sort of filter operations where we need to pop out the first element that we hit? Well, we should be using something that short circuits. Like, use some sort of search, you know, a greedy search algorithm that's going through and will terminate and not have to iterate over the entire collection. That's wasteful, because now you're talking about something that returns in a tenth of a second versus something that takes 10 minutes to return. Then yeah, that stuff matters. But that's all of that stuff is figured out as part of the design doc to sort of understand what is the nature of what we're dealing with here. Are we dealing with, small amounts of data that need to, transfer across objects really quickly? Or are we dealing with massive amounts of data that we need to think differently about how we're implementing this, and then write prototype code to validate? Like, hey, what happens if I do this versus this? Oh, we should definitely go with option B here because it's 1,000 times faster. Yeah, that would be in a design doc.
Yeah. Yeah, people tend to undervalue readability and overvalue efficiency because that's what computer science teaches. But um,
Yeah, and then I find that it happens more with like junior devs who sometimes want to try to flex in code. I've seen it in, I don't see it in like PRs and MLflow or anything, but I've definitely seen it in other projects I've worked on, where you get somebody who's a couple months out of college, or maybe they're an intern or something, and they just write something that's super complex. That's super low level implementation of something, and it's like they're trying to show you how smart they are in their code. Like, that's their only motivation. And you provide feedback. You're like, hey, what you're doing here, there's something in the language that's built in that does almost the same thing. It's a little bit slower, but it's like 40 characters to type all of that. Your implementation, that's 85 lines of code. Yeah, it's much faster. And, cool C function that you wrote. That's awesome. Now we have a compilation stage that we have to do in order to install this for this one function. Like, do we need this? What's the real purpose here? Kudos to you paying attention into, your C++ class in college, but This is not needed. So you very rarely see anybody who's somewhat senior ever doing stuff like that. Are they capable of doing code flexes? Yeah, probably more so than that junior person is even remotely aware of. They're never going to do it though. There's no there's no point. It doesn't solve any problem. It just
Yeah.
makes people confused. They're like, why did they do this way? This is really hard to read.
Yeah. Yeah, I'm excited to be able to one day A, be proficient enough in software engineering, and B, be put on projects that are complex enough to warrant seeing a senior person flex. Cause I don't think I have. And one day I will, but it'd be interesting to see. Just
I
like
mean,
the
there's tons of packages out there that are super complex when you look at them. Um,
but that warrant the complexity?
yeah. Oh
Like
yeah.
what?
I mean, if you really want to get into ludicrous levels of complexity, look at source code for languages. Like look at the core implementation of how some languages are implemented. You'll see some crazy stuff in there. Um, look at solvers for ML, algorithms. You may not know it, but you work at the same company where a lot of that stuff was invented by the people that work there. And you look at their source code and you're like, this is easy to read, but insanely complex because that's the only way to solve it, or that's the simplest way to solve this problem. It's just the problem is so complex that it's like, okay, this is intense. Look at
Yeah.
some of like the matrix based solvers in Apache Spark, like the core Scala code for that. It's intense.
Yeah. Yeah, so that's where the first point of me not knowing what the hell is going on and being able to appreciate it. That's the bottleneck, not the code existing.
It definitely exists.
Yeah.
But even those people that are writing that stuff, they're writing it in a way that is as readable and easy to understand as the problem can allow it to be.
Right.
So if you look at that code, you might not realize like, okay, this is pretty crazy what's happening here. And then you reverse engineer it and walk through like what's going on here? How is this done in a distributed system? Hang on, these are RDD operations, which are then, you know, node to node, like workers are communicating to one another pieces of this matrix and start writing it out on paper what's going on. Like, man, the person that designed this is a freaking genius about like how they thought through that. And then you ask, like, who committed this? And you're like, oh, that was Jean Rey. Yeah, you can talk to him. He's on Slack. So yeah, there's you know crazy stuff that's out there, but they're senior enough and skilled enough that they write it in such a way that is not intentionally flexing.
Right.
They're flexing, because they made it so simple. And a lot of people, if they were presented with that same problem, would write something that would be 10 times the amount of code and way more complex and less performant than it is. So it looks fancier, but true elegance is and true skill in complex software is making it seem as simple as possible. That's the end goal.
Exactly. And the first step to simple designs is a design doc.
Yes.
So, with that, I will summarize what we discussed. So, first things first, one really interesting opinion that Ben has is that process is what makes the great companies great, and it's not necessarily geniuses. People are important, but process is the key to shipping good software. And then when you're building out a design, there are a few steps. So, first, you should generally define your mission statement or your goal. Second, just build stuff, prototype, research, understand the use case. Third, you should write decisions with pros and cons and heavily think about the cons, specifically maintainability, bugs, and then basically how would people interact with that feature if they want to extend it or modify it or just use it. And then finally, get peer review. Ask people senior than you to review, ask people less senior than you to review, and just collect as much feedback as possible. And then some tangible tips. There's this concept of an implementation detail and a design decision. And that cutoff can be arbitrary, but it's typically a function of how technical you are and how technical the audience is. So setting it to the level of the reader is typically really helpful if you want robust reviews. Asking for help is important where you don't know or when you don't know where to begin, but try things first. Try Googling, try prototyping. And you don't need to do a design for everything, just the more complex things. So, anything else you want to say before we close?
No, I think that was a perfect summary.
Cool. Well, until next time, it's been Michael Burke and my co host,
Ben Wilson,
and have a good day, everyone.
we'll catch you next time.